Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to complete a given Lewis dot structure and answer questions about pi bonds and sigma bonds and sp hybridization and all that stuff. So let's get into this. So in this problem we're asked or we're given one of the first drugs to be approved for the use of the treatment or use in treatment of acquired immune deficiency syndrome, also known as AIDS, was azithromycin. So AZT for short. Complete the Lewis dot structure for AZT, and let's answer these questions. So let's first get the structure correct, because if we don't get the structure correct, we can't get the questions correct. So we got to go through and either add bonds or we got to add lone pairs. So the important thing when we're dealing with an organic molecule is the bonding patterns. So carbon and usually in an organic molecule, not always, but usually, carbon's going to have 4 bonds, no lone pairs. Oxygen is going to have 2 bonds, 2 lone pairs. Hydrogen's only going to have 1 bond, no lone pairs, right? So nitrogen loves to have 3 bonds and 1 lone pair. So you want to follow the bonding pattern, and then where the bonding pattern doesn't fit, then you do the best you can. You use figure out what works best. Okay, so if we're working this way, we see we have oxygen here. It has 2 bonds, so it needs 2 lone pairs for an octet. So we want to make sure that all atoms have an octet, right? So that's the main thing. We want to make sure all atoms have an octet, and when possible, use the bonding patterns. So we have 2 bonds, 2 lone pairs. This carbon has 4 bonds, so that's good. This carbon has 4 bonds, so that's good. This carbon has 4 bonds, so nothing needs to be done there. Now, if we go down here, this nitrogen only has 2 bonds, so we could put a bond there. Can't put a bond there because the carbon already has 4 bonds, so that's not going to work. So we could put a bond there. So now this has 3 bonds, and we could put a lone pair there. And then this nitrogen has 3 bonds. Now we could put a lone pair, but then we could put 3 lone pairs on this one. But that's not really going to be the best, because if you look at formal charge, right, we'll have too large of a formal charge. So here, if we put a lone pair there, so we got 3 bonds and 1 lone pair, so we got an octet. So the only way to give this an octet would be to have 3 lone pairs, like so. So if you look at the formal charge here, normally nitrogen has a 5 valence electron. So remember, when you're calculating formal charge, it's going to be the number of valence electrons minus 1 electron for each bond. So in this case, we'll subtract 1, and we'll subtract out all of the lone pair electrons. So we got 6 there. So it's going to be a minus 6. So that's going to be equal to a minus 2. So we'll have a minus 2 formal charge. And then here we'll have 0 formal charge. Here we'll have 0. So we have a large negative on the nitrogen. If we, instead of that, we could put a double bond here, and then this would be two lone pairs, right? So we could have two lone pairs there. And so then if we calculate the formal charge here, so for this nitrogen, it would be 5 valence electrons minus 1 for each bond. So that's minus 4, no lone pairs. So it would just be 5 minus 4 minus 0 because we don't have any lone pairs. So then we get a plus 1. And then here, it would be 5 minus 2 for 1 for each bond, so minus 2 since we have 2 bonds. And then we have 4 electrons for lone pairs, so that would be a minus 1. So here we would have a plus 1, here we have a minus 1. Lower charges, so that would be better. Okay, so then if we continue with this, then we're going around. So here I have carbon with 4 bonds. That's an octet, so that's good. Here I have carbon with 4 bonds. That's an octet. Here I have oxygen. It only has 2 bonds. It needs an octet, so I can put 2 lone pairs on here. And that fits the bonding pattern for oxygen, which is 2 bonds and 2 lone pairs. Okay, so we're moving this way. So here we have nitrogen with 3 bonds. So we would need to put a lone pair. So that gives the nitrogen an octet, plus it's obeying the bonding pattern for nitrogen, which is 3 bonds, 1 lone pair. Here, carbon has 3 bonds, so it needs 1 more bond. Plus, we have oxygen here. It only has 1 bond. Oxygen likes to have 2 bonds, so we could put another bond there. And then we could give oxygen lone pairs. 2 lone pairs, in fact. So now this carbon has 4 bonds, 8 electrons. And this oxygen has 2 bonds and 2 lone pairs. That's 8 electrons. This nitrogen has only 3 bonds. So we could put a lone pair here. So now that nitrogen has 3 bonds and 1 lone pair. So that's 8. So it fits the bonding pattern. Same thing here. This carbon has 3 bonds. It would like to have 4. Oxygen would love to have 2 bonds, so we could give a double bond there. And now the oxygen would like to have 2 lone pairs because that would give it 8. So now that oxygen is happy with 8 electrons and it fits the bonding pattern. Carbon has 4 bonds, so that's happy with 8. Here, this carbon has 3 bonds, right? This carbon has 3 hydrogens bonded to it, so that's 3 bonds, plus the 4th one here. So this carbon already has 4 bonds. We're not going to be able to give it a 5th bond, so we can't put a double bond there. If you look here, this is a popular way or common way of writing your carbon. So when you have an organic molecule, a lot of times you'll have corners or places where lines will meet, and at those meeting places, if there's no atom written, like here you have carbon, here you have nitrogen, it's assumed that that's a carbon. So if you don't see an atom written there, it's a carbon. So here we have a carbon with 3 bonds. Here we have a carbon with 3 bonds. Both would like to have a 4th bond, so you can give a bond here. So now that has a double bond. Now the two carbons have a full octet. So we've gone through the molecule. We've given all of our atoms, made sure they all have an octet, and that we've worked on, we've allowed them to have the bonding pattern that they usually have, with the exception of down here. Okay, now that we have that done, now we can answer the questions. So here we have the first question. How many carbon atoms are sp3 hybridized? sp3 hybridized means that that carbon is going to have 4 bonding groups, or I should say 4 electron groups around it, right? So again, our understanding is that sp3 means if it's hybridized, you took an S, a P, and a P, and you put those together, and you get 4 equal energy sp3 hybridized bonds. So the only way that you get that is if you have 4 electron groups around your atom that are going to occupy these orbitals. So we're looking for carbons that have 4 electron groups around them. They're probably all going to be bonding groups. Okay, so here, this carbon, we have 1, 2, 3, 4. So that's sp3. This one has 1, 2, 3, 4. That's sp3. This one has 1, 2, 3, 4. That's sp3. We're only looking at the carbons. This one has 1, 2, 3, 4. So this is sp3. This one has 1, 2, 3, 4. So this is sp3. This carbon, this double bonds are considered one group, not two. So this is 1, 2, 3 groups. So that's not sp3. Same thing for this one, carbon. This is double bond, is a single electron group. So we have 1, 2, 3 there. Again, 1, 2, 3 here. 1, 2, 3 here for that carbon. And so that's all the carbons. So if we did it right, then we have 1, 2, 3, 4, 5 sp3 hybridized carbons. So the answer here is going to be 5. How many carbon atoms are sp2 hybridized? By the same reasoning, instead of taking 1s and 3 p's, you're going to take 1s and 2 p's to make 3 hybridized orbitals. So whenever you have something that's sp2 hybridized, that means that you took an S, a P, and a P. So that's 3 atomic orbitals. You mix them together, you hybridize them, and you get 3 hybrid orbitals. Those 3 hybrid orbitals are used to house electrons where there's going to be bonding occurring. So you're going to have 3 electron groups. So the number of atomic orbitals that you mix together to get your hybrids, that's going to represent the number of electron groups that those orbitals are going to contain. So we're looking for carbon atoms that have 3 electron groups. So these are, we already took care of these. Here, this carbon, right? So 1 double bonds are 1 electron group. So 1, 2, 3. So this is sp2 hybridized. This carbon, 1, 2, 3. This is sp2 hybridized. And both of these are sp2 hybridized because we have 1, 2, and 3. And this carbon has 1, 2, and 3. And so the answer here is 1, 2, 3, and 4. Okay, oops, we forgot a carbon. So I forgot this carbon. Be careful of this because that's part of the reason why they wrote it like this instead of writing it out, because it's easy to miss. So here, this, I'm going to change this so it's clearer. so you know what I'm talking about. So I'm going to take those three hydrogens. Those three hydrogens are bonded to the carbon. So that carbon there is sp3 hybridized. So then that one, that's going to add to the number. So that means that it's not 5, but 6. So we have 6 sp3 hybridized. And for these carbons, we have 4 sp2 hybridized. So that's going to be 4. Which atom is sp hybridized? So not carbons, but atom. Which atom, one atom, is sp hybridized? So again, sp hybridized means you took an S and you took a P and unhybridized orbital, you hybridize them and you get 2 sp hybridized orbitals. So we're looking for an atom that only has 2 electron groups around it. And if you look, it's this one right here. So it has a double bond and a double bond. That's 2 electron groups. So this nitrogen is sp hybridized. So that nitrogen in the middle. So which atom? This one. Let me make this clear. So this nitrogen is sp hybridized. Okay, next we have how many sigma bonds are in the molecule. Now, when you're trying to figure out the number of sigma bonds, the assumption is always that if you have a bond between 2 atoms, it's always going to be a single bond, right? If you have multiple bonds between 2 atoms, one of them has to be a sigma bond. Remember, the sigma bond is the bond that's formed along the axis due to the overlap of the orbitals. So the orbitals that are overlapping, they're overlapping for the sigma bond between the 2 atoms along the axis that's connecting those atoms, not outside the axis, but directly between the atoms. So that's what a sigma bond is. So if you have a single bond, there's only one sigma bond, right? Because you only have one bond. If you have a double bond, then you've got one sigma bond. Anything beyond the one bond is going to be a pi bond. So if you have a double bond, it's going to be one sigma and one pi bond. If you have a triple bond, then it's going to be one sigma bond and 2 pi bonds. So if you've got a bond between atoms, that's going to be at least one sigma bond, right? Or I shouldn't say at least, but I should say it's going to be a sigma bond, right? So anytime you have a bond between atoms, it's a sigma bond. So here you have 1. So all we have to do is just count all the bonds, including double bonds. So here we have 1, 2, 3, 4, 5. So this is where you got to be careful of counting, right? So you got to make sure you count everything correctly. So 1, 2, 3, 4, 5. And then I'm going to work my way around. So 5 is this one. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. I counted this one already, so I have 19. So then this is going to be 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. And then come back up here, 30, 31, 32, 33. So 33 sigma bonds, if I counted correctly. If I missed one, please let me know down below. It happens. Okay, so Oops, wrote it in the wrong place. So we have 33 sigma bonds. Now, how many pi bonds are there? Pi bonds are, as I said, going to be where the multiple bonds are, double and triple bonds. So if you have a double bond, one of those bonds is automatically a sigma bond. You're only ever going to have one sigma bond between atoms. You're not going to have two sigma bonds between atoms. You're not going to have three, only one. If you have multiple bonds between atoms and one of them has to be a sigma bond, whatever's left over has to be a pi bond. So here we have a double bond. One of those is a sigma, the other one is a pi. So that's one pi bond. This double bond here, same thing, one sigma, one pi. So that's two. Here we have a double bond, so we have a third pi bond there. Here we have a double bond, so there's going to be a fourth. And then here we have a fifth. So that's 5 pi bonds. So we're going to write that down right here. How many lone pairs are in this molecule? So let's count the lone pairs. Again, be careful you don't skip one. So we have 1, 2, working my way around, 3, 4, 5, working my way around, 6, 7, 8, 9, 10, 11, 12, 13, and that's it, 13. So we have 13 lone pairs, 13 lone pairs. Okay, next, what is the NNN bond angle? Where's NNN? Right here. So NNN. So what's the bond angle around this central N here that's sp hybridized? So notice you have two electron groups. According to VSEPR theory, the electron groups want to be as far apart as possible. So they're going to be on opposite sides of the atom. So you're going to get a linear shape. So therefore, it's a line, it's a straight line. Therefore, the angle is 180 degrees. So 180 degrees, and that's because it is linear, and that's because it's sp hybridized. And last but not least, what is the hybridization of the oxygen atom in the the CH2OH group? Where is that group? Right here, CH2OH. So this oxygen here, you want to know what the hybridization is. Again, hybridization is dependent upon the number of electron groups, whether they're bonding or non-bonding. So if we count the electron groups around the oxygen, we have 1, 2, 3, 4. So 4 electron groups means that we need to take 4 atomic orbitals. So remember, when you're taking atomic orbitals, you work your way from low energy to high. So you'd go use up the S first, then use up the P's. If you need more, then you go into the D's, right? So here, we only need 4. So we're going to take an S, a P, a P, a P. So that's 4. We're going to mix those together, and we're going to get the 4 equal energy sp3 hybridization. So the answer is sp3. So this oxygen is sp3 hybridized. And that, ladies and gentlemen, is the end of the video. That's how you answer this question. I hope this was helpful. If it was, if you enjoyed this video, then please, by all means, like the video, share the video, hit that like button over there. Also, do me a favor, help me out here. Subscribe to my channel if you haven't already. And also make sure you click on that notification bell. And when you do that, click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you'd like me to cover, let me know. I would love to do that. Thanks for joining me, and have a great day.